So to determine theoretical and percent yields, you first need to know that theoretical yield is the amount of product formed when the limiting reactant is completely used up, and the percent yield is when you use an actual yield from experimentation and you divide it by the theoretical and times by 100 to see the actual percent yield. So here you're given this equation and it says if 2.5 metric tons of Cu3FeS3 is reacted with excess oxygen gas and the process has an 86.3% yield of copper, what mass of copper is produced? So first you want to find out the theoretical mass of copper that can be produced, and you can do that by using dimensional analysis. So first you know that you have 2.5 tons and you know that 1 ton has 1,000 kilograms and 1 kilogram has 1,000 grams, and in 1 mole of Cu3FeF3 there is 342.71 grams. That's the molar mass of this, and then in 1 mole of Cu3FeS3 there are 3 moles of Cu because of 3 in the subscript. And then you need to use the molar mass of copper, so then you do 1 mole of copper is the molar mass of it is 63.55 grams. And then you multiply all of the values in the top and divide it by the bottom, which will get you to 1.39 times 10 to the 6th grams of copper. And this is the theoretical. Now, you have the theoretical and you have the percent yield. So to determine the actual, you can just plug all of it into the percent yield equation. So you have the theoretical, which is 1.39 times e to the 6th. And to move this around to the actual, what you would do is, to get to the actual, you would divide the percent yield by 100 and multiply by the theoretical. So what you would do would then multiply this by 86.3%, and then which gets you to 1.2 times e to the 6th grams of copper, which you can simplify to 1.20 times e to the 3rd kilograms of copper, which then can be simplified even further to 1.20 tons of Cu, which is the actual amount of Cu produced.